Good afternoon, everyone. I'm Professor Sabbatini from RMIT, from Khalifa University. I'm also an honorary professor at RMIT University in Australia, so I try to build bridges across continents. And, my presentation today is about how we tackle the challenges of industry, focus, research, and training, right? Something that university is not particularly familiar with, right? So, especially in a changing airspace, right? So the Falcon Center program, Center for Flight System Research Training, is exactly doing that. And it's doing it as a collaborative endeavor with industry, primarily nationally and internationally. So what's happening in the airspace, right? You've been hearing a lot about the changing happening in low-altitude airspace. And so the most of the transformation for both urban and regional air mobility are occurring in low-altitude airspace, right? And so below the current flow of controlled airspace, this is the boundaries of conventional air traffic management. So where large commercial passenger aircraft or business aircraft take flight, right? So they're still going to be there, also integrating with unmanned aircraft systems. And then the low-altitude ATM framework is evolving. The regulations are not there, right? So there are huge evolutions taking place in terms of the key enablers, not just technologies, all right, but also policies and regulation that will ultimately allow both the airspace to be dynamically managed and platforms to be certified in terms of not just the conventional kind of airframe and propulsive system, but avionics. So increasingly, there's a shift of focus toward more digital and more sustainable flight, right? Because flying at low altitude, you have a number of additional challenges, right? Emissions, gaseous emissions that are both having like long-term greenhouse gas sustainability impacts, and noise, perceived noise on the ground. Well, now it's a big challenge. And so there are also other things going on. So the airspace is evolving also at high altitude. I'm sure you're aware of the initiative from NASA or the FAA and in Europe, like for high altitude operation above flight level 600, with new platform coming, high speed. So how is this all going to affect the ecosystem, right? And of advanced air mobility. Advanced air mobility itself includes a huge number of platforms, right? And many original equipment manufacturers there have been very active and working mostly on three categories, right? So multi-rotor, vector thrust, and lift for cruise, right? So as we call them. And so, and many of them are doing the same thing. And there is a strong focus on tilt rotor, but others are bringing new opportunities, such as we have Manta stand today, which we can look at, one of our collaborators. So an aircraft that is very interesting with ducted fans and the ability to effectively extend the envelope and bridge together the envelope, fix a rotary wing in the same aircraft. Now, in advanced air mobility, there are a number of challenges. And so, first of all, we need to understand the overlaps from an airspace and from a platform perspective, the unmanned aircraft system traffic management framework, right? We need to understand that. And we also need to understand the interactions with the built environment. Okay, we're flying at low altitude in the presence of building, and so vertiports also most likely will be built on top of buildings. So how all these evolutions in terms of platforms and infrastructures are going to interact with each other? So at Khalifa University, we are tackling these challenges, mainly addressing a very focused areas. All right, we don't do everything, but what we do very well. Okay, so and we educate our students, both undergraduate, postgraduate, and PhD students, to deliver the very best to our industry partners. So in the UAE, there is a very strong business case. This became very quickly the long-range aviation hub in the world. All right. So building urban and building a regional air mobility framework become very significant. So to do that the right way, you know, to look at how automation and autonomy is revolutionizing air traffic management for UTM, so US traffic management, but also for conventional ATM. Advanced air mobility itself is not just urban air mobility. The business case for that is limited, it's clear, and it's predominantly regional air mobility, so we should insist on that. And there are complementarities between the two, not competition. There is complementarity. Sustainability is big, right? So how digital avionics and air traffic management systems evolution in the proper framework for certification can enhance the performance and enable advanced navigation and guidance system to operate, as well as obviously developing and accumulating all the evidence for certification. And so these are the key challenges that we are addressing in university. How we do it? Well, we don't do it in the conventional way. So did you know that globally, university have, if you look at all ideas that are generated in publication, only 1.5 to 2% ever become a product or a service. So would you invest in a business that has like 1.5 to 2% turnaround? Doubt it, right? So we are trying to change that kind of value proposition with a unique value proposition, the Falcon Center. So effectively, there are opportunities for research, all right? That's very important, and training in all phases of the life cycle. So typically, universities stop around about here with a conceptual design definition, so a very high-level design concept, all right? How many of those concepts, TRL 2.3, ever become a TRL 9? You need TRL 9 if you want to deliver a product and a service, right? So we believe there are opportunities in all phases of the life cycle, down to detailed design where the specs are produced, the actual hardware and software development, the coding or the manufacturing, and then eventually also during the test and evaluation phases, which, by the way, are integrated. That's something I took that from the Royal Academy of Engineering. It's not mine, right? But these are integrated. So by modeling and simulation, that's what means that by modeling and simulation at the early stage of the life cycle, you're already producing evidence for certification. And so there are opportunities for research at all levels, even during the operational phase. And then this loops back. So the aviation industry and the aerospace industry, so the operational domain and the design, development, test, and evaluation domain are linked, are tightly coupled. In advanced air mobility, this is even more essential than in conventional aviation, right? There are not the huge monopolies that, exist in the aviation context, in the conventional aviation context. So at Khalifa University, the Falcon Center is effectively going from initial proof of concept, right, to TRL 3, down to prototype and product design, TRL 5, so where effectively concept is validated in a simulated environment, still in the lab, and limited flight testing. And then we go into flight testing with a full demonstration in the real environment. Okay, how we do it? Obviously partnering with the right industry and government partners, right? In the UAE, we have this huge opportunity. And so I'm sure you're familiar with the NASA AAM framework. There are many areas, right? The vehicle is only part of that. So we need to develop airspace system design and implement them properly. There are challenges on airspace and fleet operation management, the vehicle itself, and then also individual vehicle management and operation, as well as, very important, the societal acceptance. So why? Well, air traffic management is natively a cyber, physical, human system, right? And that is evolving into a cyber, physical, social system. So where effectively the social interactions play an important role in all aspects of the decision-making, in all phases of the life cycle, and during operation as well, right? So now intents for dimensional trajectories, as we call, are negotiated and validated in real time. And so, and in the advanced air mobility context, the airspace morphs in real time according to demands. So to maximize capacity-demand balances, something that conventional aviation is doing in the context of air traffic flow management is now becoming a real-time task. All right, so a real-time air traffic management task. So again, as I said, advanced air mobility is not just urban air mobility. I think it's even more regional air mobility. And so there are many business cases associated to operation both in urban and rural location and remote location, connectivity between cities. So we're moving toward trusted autonomy. So this need is absolutely clear. You can't have conventional platforms with a human pilot in dense airspace. That has been clearly defined and assessed already during the UTM framework research by NASA, right? UTM level 4, which is the urban density of urban air regional environment, simply not possible. So you need a high level of automation and trusted autonomy. Now, in this context, there is a big challenge. The tasks and responsibility of human air flight systems in the UTM, AAM context are yet to be defined. And so there are huge challenges, but indeed also enormous opportunities for investment, right? Which I would like to bring to your attention. And within my research group and the Falcon Center, we're really working hard to make this happen. And so, looking in particular at two main areas, right? The evolution of trusted autonomous system. Bear in mind that as of today, we only have semi-autonomous system in the airspace. So these are autonomous only in predefined conditions. So not in all portion of the aircraft operation flight envelope. And so that's one of the current limitations which we are trying to remove towards trusted autonomy. Trusted autonomy is not just autonomy. It's autonomy that is trusted by the human, all right? But to be trusted by the human, there must be a sort of closed-loop interaction with the human operator itself. So if you wish, the next level, adaptive human-machine systems. So systems that are able to modify the interfaces, interactions, including command and control functions, and the level of automation based on two things: the ability of the platform to perform and the ability of the operator to perform. So now it's like now having machines making a real-time assessment of the ability of the operator to perform. And there are obviously a huge amount of ethical implications as well as regulatory implications associated with that. So we are doing that in the presence of specific hardware constraints. So what we have nowadays in terms of equipment, uncertainty in physical processes, the variability of traffic and mission requirements, right? And also the possibility of both cyber and physical attack and human errors. So this is like a huge challenge, but as I said before, this represents also a huge opportunity for the community. And so, working with industry, we have identified these key challenges in the area of AI. AI has been heavily researched, right? Because that's an enabler for trusted autonomy. Both systems, autonomous system and closed-loop human-machine systems. And so, how are we going to do it? Well, there is a need to obviously develop new functionality, new algorithm. But the algorithmic intelligence is already very advanced. There is even a stronger need to be able to certify that capability. So the airworthiness of AI, that's a big challenge. And so we are working very actively with the industrial community to develop new form of AI, but also working with them to develop new certification framework that ultimately will enable integrated and interoperable, I apologize for the acronym, it's communication, navigation, surveillance plus avionics. So it's air traffic management and avionics blend is an acronym that's been coined by the Boeing about 10 years ago, and we've been very proactive in effectively developing the system that enable that. These are cyber-physical systems, and heavily and increasingly intelligent cyber-physical system based on AI, which only in this way can the community have the key enabling capability of trusted autonomy for unmanned ecosystem access to all classes of airspace, but also improving efficiency and capacity that require both digitization and multimodal. Okay, so very important. Advanced air mobility itself, without a multimodal integration, right, is not only inefficient, is also unsustainable. Right, so let's be clear about that. So this is not replacing conventional forms of transport, but integrated with them. And I think this event shows the need for a multimodal integration. And so new solution also to enhance security and safety and security. That is not just cyber security. A lot of people talk about cyber security, the threats associated with AI. No, it's a cyber and physical security problem, right? Because in the cyber physical world, some of the threats are injected in the physical dimension and reflect in the cyber dimension, and some threats are injected in the cyber dimension and reflects in the physical dimension. So don't forget that. And this is going to have a huge impact in the way we design and certify the systems of the future. Thank you very much.